This question, you can see we have a large school of which 20% of students own a touchscreen laptop. We take a random sample of n students from that school, and it says using a normal approximation, the probability that more than 55 of these n students own a touchscreen laptop is 0.0401. Correct to three significant figures. Find the value of n. Okay, so this question has told us to use a normal approximation. Started off as a binomial distribution. Reason for being is that you can either have a touchscreen laptop or you can't. So we start this one off by setting out what the binomial distribution would be. And we pick n, which we don't know, and we have the probability is 0.2. In order to switch this to using a normal approximation, we need to know both the mean and the variance in order to set up that normal distribution. To find the mean, or an estimate for the mean, we do n times p, so that will be 0.2n. And to find the variance, we do n times p multiplied by 1 minus p, which in this case is 0.16n. Okay, so we need to define what our variable is going to be. So it's useful to switch to y. So we're going to let y that's now equal to the number of students who own a touchscreen laptop. This gives us a normal distribution of the mean, which we've said is 0.2n, and the variance 0.16n. Okay. Next thing that we're going to take from the question is the number that we have. We've got a probability of more than 55. But note that was when it was a binomial. So we had probability of x being greater than 55. When we switch that to our normal approximation, it's going to be approximately equal to y being greater than or equal to 55.5, because remember we have to take that continuity correction because we've now switched to essentially continuous data. Now, when we try and write that probability, because we don't know what our mean is and our variance are, we need to use the standard normal distribution. And the standard normal distribution, as you know, involves z now being greater than, and we write down our number for y, which is 55.5. We subtract the mean, which is 0.2n, and we divide, and be careful with this, we divide by the standard deviation. So when we divide by the standard deviation, you know from the probability given to us in the question that that would be 0.0401. Okay. Now, consider the calculator that we have available to us. The calculator will always give us a probability of less than or equal to. So it's just worth considering if the probability of it being greater than or equal to is 0.0401. Probability of it being less than or equal to will be just simply 1 minus that. And when I do 1 take away 0.0401, I get 0.599. Okay, so I'm going to rewrite that now because this will allow us to look it up on the calculator as z being less than or equal to 55.5 minus 0.2n all over root 0.16n. And that, of course, is now equal to 0.9599. Okay, so we've had to do all this because we are going to use the standard normal distribution. Now we have this set up, we can look up this particular value, that particular probability, and find out what Z value that returns. That Z value will then allow us to solve for n. That's going to involve us using our calculator. So we go onto our class whiz, we press menu, we go to distribution, and this one we are going to use the inverse normal. Okay, 3 things to put in here. Our area is that probability that we had, so 0.9599. And our standard deviation is 1 and our mean is 0, because remember the standard normal distribution has those 2 values. We just check they're in there and it delivers a result of 1.7495 and so on. We don't need to take too many decimal places there. The question itself is asking to 3 significant figures, so if I take this to 5 significant figures, that should give us enough accuracy. So now I could rewrite my equation not involving Z anymore. So I've got 55.5 minus 0.2n all over 0.16n, and that equals that number that's been returned on the calculator. So I'm going to take this to 5 significant figures of 1.7495. And from this point onwards, we are just going to solve for n. Let's have a little bit more room. So first things first, multiply through by root 0.16n. So when I do that, left-hand side is 55.5 minus 0.2n. And the right-hand side, when I do 1.7495 multiplied by root 0.16n, you end up getting 0.6998 root n. So what I've done there is I've taken the root 0.16 out and multiplied that by 1.7495 and left the root n there. Okay. So now what you can possibly see is that we have the makings of a quadratic equation. So if I rearrange it first to get it all to equal 0, I have that. And we've seen these before in pure maths. And what we can do is we can let root n equal a, and then rewrite it as a quadratic. So then we get 0.2 a squared plus 0.6998a subtract 55.5. So there we have a quadratic equation to solve. So once again, return to our ClassWiz calculator, and we go to menu, and you go down to equation. This one we're solving a polynomial. The degree, highest power in this is 2, and we enter in our figures into there. So I've got 0.2, 0.6998, and minus 55.5. Check all the numbers in there are correct, and we get 2 solutions in there. So now I get root n to equal 15, it's a round number, or we get root n to equal minus 18.5. Okay, that second solution we can discard as it is not a real value. Okay, so cross through that. We're going to discard that one, and we're just going to work with root n being 15. So therefore, n is 225.